Section 4-6, Completing the Square, Part 1. Today, our learning goal is going to be that students will be able to solve equations by completing the square. In this section, we are going to have a lot of radical and square roots, so we are going to practice simplifying them before we move on to actually solving. First, we are going to look at the multiplication properties of square roots. If you have two numbers under a square root that are being multiplied together, you can separate them and take the square root of both separately and then multiply them together. Now we're going to look at the division property of square roots. If you have two numbers that are being divided under one square root, you can separate them by taking the square root of the top number and then taking the square root of the bottom number. The first example we are going to look at is just a very basic one. You can take the square root of 81 and it gives you the nice number of 9. In example 2, if I were to try to find the square root of 18 using my calculator, you would find out that it gives you a decimal. So to find out what the answer of this is, we would need to think of two numbers that multiply together that give me 18. I know that's going to give you lots of options, so you definitely want to think of a perfect square times another number that would give you 18. So I know that 9 is a perfect square, and 9 times 2 is 18. Now I can take the square root of 9 and it gives me the number 3. I can't take the square root of 2, so it stays square root 2. A lot of you guys might have also done the factor tree, which that works as well. Break it down to 3 times 3 times 2. Since it's a square root, you need two of the same numbers to come out front. Whatever you can't circle is what stays underneath. So either one of these ways works for you. Whichever one you like better, please use that option. Example 3, we have 5 times the square root of 320. So you're either going to break down your 320 with your factor tree, or think of the largest perfect square times a number that gives you 320. So I'm going to do it both ways. So if you find a perfect square times another number, that's going to be 64 times 5. The multiplication property says that you can break it down into the square root of 64 and then times the square root of 5. The square root of 64 is a nice number of 8. And then you can't take the square root of 5, so you bring down your 5. And then don't forget about the fact that you had a 5 out in front, so you have to do 5 times 8 since they are both out in front. And your final answer is 40 times the square root of 5. Let's do the factor tree way now, since that'll give you the same answer. So I know 32 times 10 gives me 320. Now we need to break down 32 and we need to break down 10. So 32 is 8 and 4, 8 is 4 and 2, 10 is 5 and 2. If you wanted, you could break the 4s down more, but I see that here is 2 4s, here is 2 2s, so 4 times 2 is 8. The 5 that was not circled stays underneath my radical, and then I still have to do 5 times 8, which gives me still an answer of 40 root 5. So whichever way works for you to simplify your radicals, do that way, so that way you can get your right answer. Example 4, we have the square root of 9 divided by the square root of 4. So your division property allows you to take the square root of the top and then the square root of the bottom. The square root of 9 is 3, the square root of 4 is 2, so your answer is 3/2. Example 5, we have the square root of 13 divided by the square root of 25. So again, we are going to separate them by taking the square root of the top and the square root of the bottom. I cannot simplify the square root of 13, so it's going to stay the square root of 13, and the square root of 25 is 5. So your answer is square root 13 over 5. Example 6 is going to be our last example talking about simplifying radicals, and this one is a little more difficult than all the other ones. So I have the square root of 16 divided by the square root of 3. So again, I'm going to take the square root of the top and then the square root of the bottom. The square root of 16 gives me a nice number of 4. The square root of 3, however, I cannot simplify. Now, you are never allowed to leave a radical in the denominator. So, to get rid of my radical in my denominator, I have to rationalize my denominator. So I have the square root of 3 in the bottom, so I need to multiply both the top and bottom by the square root of 3. These things need to match each other, so that way my radical in my denominator goes away. So 4 times the square root of 3 just gives me 4 square root 3. You just stick it next to each other. And then when they're both under the radical, you can multiply them together. So 3 times 3 gives me the square root of 9. You know that you can simplify the square root of 9 as just the number 3, and you cannot simplify the top any. So your final answer is 4 square root 3 divided by 3. Now we're going to look at actually solving these equations by finding the square roots. In example 7, we have 7x squared minus 10x equals 25. So your first step is going to get everything away from this x squared term. So my first step is going to be to add 10 to both sides. So that gives me 7x squared equals 35. Now I have to get rid of the 7 that's in front of my x squared, so I divide both sides by 7. So that gives me x squared equals positive 5. And to get rid of something squared, we take the square root of both sides, and that gives me x equals. So every time you take the square root, you know x squared means that there should be two answers. So it's plus or minus. I cannot simplify the square root of 5 anymore, so it's x equals plus or minus square root of 5. Remember, every time we were looking at our parabolas when we were using our graphing calculator, x squared means you have two answers for x. So that's why you're going to have the plus and the minus. Press pause, and I want you to solve 2x squared plus 9 equals 17. You need to isolate your x squared, so the first step is going to be subtracting 9 from both sides. So 17 minus 9 gives me 8. Then I have to get rid of my 2 that's in front of my x squared. So that leaves me with x squared equals 4. And then to undo your squared, you take the square root of both sides, and the square root of 4 gives you an answer of positive and negative 2. Now we are going to look at solving perfect square trinomial equations. In example 9, we have x squared minus 14x plus 49. So we are going to go back to our factoring skills that we remember. And remember, I always told you the first thing that you should check is for the shortcut for if it's a perfect square trinomial. So you need to ask yourself, can I take the square root of x squared? And you can. And then you need to ask yourself, can you take the square root of 49? And you can. And then is the middle term 2 times the square root of this times the square root of that? And it is. So we're going to go ahead, we're going to take the square root of x squared, which leaves me with x. We're going to take the square root of 49, which leaves you with 7. Now this is the part a lot of you guys struggled with when we took our quizzes. Whatever sign is in front of your b term is what sign that goes in between your two terms. Put parentheses around it and square it, and then we're just going to bring down the equal sign and then bring down the 25. So now to undo something that's squared, because x minus 7 is squared, we're going to take the square root of both sides. So the square root of something squared just undoes it, and you're just left with x minus 7. The square root of 25 is going to be plus or minus 5. Now I'm going to write my two equations so I can solve them both separately. For x, so x minus 7 equals positive 5, x minus 7 equals negative 5. Now add 7 to both sides, and you get that x equals 12. Add 7 to both sides, and you get that x equals 2. This is our last example, so press pause, and I want you to solve 4x squared plus 12x plus 9 equals 5. So right now, the only thing you have learned is the perfect square trinomials. So that's what we're going to do. Remember, you always want to check this shortcut before you move on. So the square root of 4x squared leaves me with 2x. The square root of 9 leaves me with 3. And then whatever sign is in between, in front of your b term, is what comes in between them. Put parentheses around it and square it, bring down your equals, bring down your 5. To undo something that's squared, we take the square root of both sides. The square root of something squared just undoes it, and you're left with 2x plus 3. I cannot simplify your square root of 5, so you just write plus or minus square root of 5. Now, to get x all by itself, now you could write two equations, but since I can't simplify the square root of 5, you don't have to. I'm going to subtract 3 from both sides. Now, you cannot subtract 3 from a square root, so you just write it out in front. So I have negative 3 plus or minus the square root of 5. And then you divide both sides by 2. And when you divide, you would be simplifying this number and this number. So my final answer is x equals negative 3 over 2 plus or minus the square root of 5 over 2. And that's your two answers.